Uh, Let us solve one more problem. So this is the problem. So this is very easy problem, but I want to show you the importance of the constant. So this can be easily variable separable. So dy will be cos x dx. Integrating on both sides. Y will become integral of sin x dx plus c. Or like this you can write. So y will be integral of sin dx sin x is minus of cos x and plus c. Sorry, it is cos x now. So answer will be sin x. Now here, if sometime he want answer in graphical method, so in graph, what will be the graph for this? So because I know the answer is sin x. So if y is equal to sin x exactly, for c equal to 0. So if c is equal to 0, so you can draw this curve, sine curve, simple sine curve. Okay, so this is for c equal to 0. Because this constant value can change. If suppose c value is positive, so that time height of this will increase. Curve shape will be same. So like this it will be. Suppose this is for c is equal to 1. So it will touch here at 1 like this. If it is c equal to minus 1, so then it will touch at minus 1. So then shape will be same. So like this curve will be. Okay, so I want to tell you the importance of this constant. So on constant also it will depend, and then for this constant it will be a family of curve. You will not get single value, it is a family of curve, different curve you can get for this. Okay, so this type of option also can be available in the exam. Sometimes they can give you single also, sometimes they can ask you family of curve. So be ready for that also. Just little bit mind only you have to apply, otherwise it is okay. This answer is okay. Note down this. Because what happens sometimes a student can solve up to here, but they do not understand this. What is this? Okay. Second order ordinary differential equations. Okay, so first order finish all type. Now in second order ordinary differential equation, we will find homogeneous. In homogeneous differential equation, they will be of the form d2y over dx square plus p dy by dx plus q into y is equal to 0. So these are the homogeneous type. and second type of equations are non-homogeneous. The form will be same, but in place of 0 at the right hand side, there also will be a function of x. Here p, q, y, so p, q, r are function of x. R is function of x. P, q, r are function of x. Okay. Now, in this form, operator we can write operator fd is equal to d square plus pd plus q. Okay, this operator I will take out operator. You take out y from here, y from here, y from here, and then whatever the operator left, like this you can think it, d2 over dx square plus d by dx plus q into y is equal to 0. So this can be written as this d square by dx square, I am writing d square, d by dx I am writing d, and sorry, p is also there now, pd, and plus q into y equal to 0. So this is like this is some operator which is applied on y, and that is equal to 0. So this operator I am telling that this is the fd. Okay, so in this form we can write the operator fd equal to this, where here d square is d2 by dx square. For that I'm using the word d square, and d is d by dx. Okay, so these are the two replacement. P and q already I told you that this is the function of x. Okay, so note down this. Okay. Okay, so next what we can do, now we have to learn the procedure, how to solve the problems. Okay, procedure for solving the second order differential equation. Number one, we have to learn for homogeneous. So homogeneous, d2y over dx square plus p dy by dx plus q y is equal to 0. So for this, what you have to do first, you have to find the auxiliary equation. Okay, write or put, or you can say this I can write in the form of fd into y is equal to 0. That I can write. You understood now what is the fd? Fd is d square plus p d by dx and plus q. That is the fd. So you can put fd equal to 0. So once you put fd equal to 0, this is known as auxiliary equation.
Sir, is it same as the given equation? Already it is 0, RHS.
RHS is 0? No, I am telling only FD you put equal to 0 because from here I want to find out the roots. Understood?
Yes, sir.
So here FD equal to 0 means D square plus PD plus Q, that you will put equal to 0. And this is a quadratic equation. So it is a quadratic equation. We get two roots. We get two roots of this equation. Okay. Now the question comes. Number A. If these two roots, it depends upon the two roots. If two roots are real and distinct, then y will be equal to c1 e to the power m1x. Suppose these roots are m1 and m2. m1 and m2. So the answer will be c1. c1 is a constant, e to the power m1x plus c2 e to the power m2x. So like this we will take the answer. So in green function I have utilized this technique only. So this procedure I have applied in the Green's function. So now you can correlate. Okay. Someone was asking why we are taking like this, or somewhere we take c1 plus c2x into e to the power mx. Why we take that? So all the doubt will be cleared here. Now the next thing is, if the roots are real and equal, they are not distinct. If two roots m1 and m2 are real and equal, so once they are equal, so they will become m1 equal to m2 equal to m, suppose. Then solution y will be c1 plus c2x e to the power mx. This will be the answer. So this we have utilized in green function. So you can correlate now. Note down this.
Sir.
Okay. Now third type. If roots are complex, okay, so these complex roots I am taking as alpha plus minus I beta. So here m1 is alpha plus I beta and m2 is alpha minus I beta. Means roots are same, only plus minus is there. Okay, so alpha plus minus I beta, this kind of roots are there. Okay, so answer will be y equal to e to the power alpha x. Alpha will be utilized here. Then a cos alpha x plus b sin beta x. So here both you will be used. Sorry, here it is. Alpha I have used here and beta will be utilized inside. So this type of solution also I have used in green function. You can correlate this also, because there plus minus I was there. Once it was d square plus 1 equal to 0, we have taken it d square equal to minus 1, d equal to plus minus I. Here alpha value is 0. So we have used the y equal to a cos x plus b sin x. Like this we have used. Okay. So you can correlate it. Okay, one more case can be there if sometime this is repeated. Okay, if these roots alpha plus I beta and again alpha plus I beta, means if we have d to the power 4 plus 1 equal to 0. So in that case, I will get d equal to plus minus I and plus minus I. No, it will be different. Okay, but there may be some other example, which will have that these roots are repeated. So we can write here, if roots alpha plus minus I beta are repeated twice. Okay, but the such case will not be given in your exam because it will become lengthy. So y will become e to the power alpha x. Here in place of single constant, you can write here a and b are constant. So here two constant I need for this also. C1 plus C2x into cos beta x plus this one will be C3 plus C4x into sin beta x. So this type of solution can be there, but it will be lengthy. So up to here only it is sufficient, up to C. Okay, but one more I will tell you. If pair of roots of auxiliary equation is irrational means roots are in pair and it is irrational, that is alpha plus minus under root beta. Irrational means suppose it is under root 3, so directly I cannot take it. Suppose it is under root 4, it is 2. So this is a real number and rational number, but this number is irrational like this, because it will give you some answer in 1 point something. Answer is in point. So that's why it is irrational. So if such kind of roots are there, so then directly you can take, but here beta should be positive. Otherwise it will become imaginary. Okay, and that will become the complex case that I am not discussing here. This is positive, so that's why positive and irrational, it will become total irrational. So then y will be e to the power alpha x c1 cos hyperbolic under root beta x. This under root beta as such I will take, but answer will be in cos hyperbolic. If it is imaginary, so then it will become just normal cos beta x plus c2 sin hyperbolic under root beta x. In place of c1 c2 you can take a and b, that is not an issue, but this form you have to remember for the answer. So this type of question we will solve one by one. You can note down the method.
Sir, in the case D, is there only two boundary conditions?
Boundary condition can be everywhere that we can apply. Just I am telling you the procedure. Here 4 boundary conditions are required because 4 constants are there to get that. But I am telling you the procedure. What is the procedure to get the solution? If boundary condition is given, then only you can find out the constant, and that can be put. So that depend upon the question. If it is given, then answer will be without constant. If it is not given, so with the constant only we can give the answer.
Yes, sir.
Done?
Done, sir.
Okay, so let us solve problems now. Question is solve y double dash plus y is equal to 0. And it is given boundary condition that y at 0 is equal to 3 and y dash at x equal to 0 is minus of 0.15. Okay, so see here, two boundary conditions have been given because two constant will be there. So for both of them we can find out. So exact answer we can find out. If boundary condition not given, so then answer will be in constant form. Aswik. Okay, so here we can write this equation d2y over dx square plus y is equal to 0, or we can write d square y plus y is equal to 0, or we can write d square plus 1 into y is equal to 0. So this is my FD. Okay, so what is our correct procedure? Put auxiliary equation. Auxiliary equation is put FD equal to 0 means d square plus 1 equal to 0. So from here d square is minus 1. So d will be plus minus I. Okay. So these are the two roots. And I told you that it is alpha plus I beta. Alpha value is 0. Alpha plus minus I beta. So here alpha value will be 0. Beta value will be 1. So what will be my solution? Y equal to e to the power alpha x a cos beta x plus b cos beta x. So e to the power 0 a cos 1 x plus b, sorry, it is sin b sin x. So this is the answer if boundary condition are not given. Now here boundary condition are given, so you can directly put at x equal to 0, y is equal to 3. So this implies 3 equal to a cos 0 plus b sin 0. So this is already 0. So a is equal to 3. Okay. Now you can get y dash, because y is this much. Y dash will be how much? Y dash will be minus a sin x plus b cos x. Now for y dash also I have an answer. At x equal to 0, y dash is equal to minus 0.15. Understood? So that I can put here. That will be equal to minus a sin x. So that will become 0. only b will be remaining. So that will be the value of b. So b is minus 0.15. Hence, final y will be 3 cos x minus 0.15 sin x. Note down this.
Sir.
Okay, one more thing we can do here. Sometime he can ask you graph. What will be the graph for that? Okay, so graph actually in such cases we can just guess. We cannot give it correctly. We can how to guess means at x equal to 0. What is the position at x equal to 0? Because this is the 0 point. At x equal to 0, what is the value of y? 3. It means graph will cross here. And then I know that this is cos x and sin x combination, so definitely it will be oscillatory. So then you can make it. Okay, so starting from here, just a starting point you just know and you can make it. It is oscillatory only. Okay. Now coming to next question. Solve d2x over dt square minus 3 dx by dt and plus 2x is equal to g. So now tell me what is fd here? Fd will be d square minus 3d and plus 2, or you can write it d2 or dt square minus 3d by dt and plus 2 into x is equal to 0. And this thing you can write d square, this thing you can write d. So I'm writing it this. Okay. So boundary conditions are also given. Then they are asking what is value of x2. At t equal to 2, what is the value of x? It means you have to find out the x first. Then in that you can apply these boundary condition. With that you will get the constants, and in that you can put x t equal to 2. Then what is the value of x? Okay, so note down it first quickly. Done. Okay, so auxiliary expression will be fd equal to 0 means d square minus 3d plus 2 is equal to 0. So here 2 1 ja 2, it can be written minus 2d minus 1d. So d square minus 2d minus d and plus 2 equal to 0. So d can be taken common. It will be d minus 2. Minus 1 can be taken common. D minus 2 equal to 0. d minus 2 throughout the common, d minus 1 equal to 0. So d is equal to 2 and 1. So these are the two roots. So these are real and distinct roots. So what is the solution for that? So solution is y equal to, can anybody tell?
C1 e to the power x, C2 e to the power 2x.
C1 e to the x. Actually here x and t, in place of y it is x and in place of x it is t. So C1 e to the power 1 into t plus C2 e to the power 2 into t. That will be the answer. Okay. So now you have to apply boundary conditions. So what are the boundary conditions? X0 equal to 0, x1 equal to 1. These are the two boundary conditions. Okay. For t is equal to 0, x is equal to 0. So this implies 0 will be equal to C1 e to the power 0 plus C2 e to the power 0. So this implies C1 plus C2 is equal to 0. So this is one equation. Okay. Or you can say, or you can replace C2 is equal to minus of C1. Hence, x will become C1 e to the power t minus C1 e to the power 2t. So only one function left now. So it will become C1 e to the power t minus e to the power 2t. So this is my x. Now I will apply second boundary condition. Then we will get the both constant. Note down this. Manu, your mic is on.
Sorry, sir. Done, sir.
Okay, next boundary condition at t equal to 1, x equal to 1. So this implies 1 is equal to C1 e to the power 1 minus e to the power minus 2, sorry, plus 2. Okay, so C1 value will be C1 value will be 1 upon e minus e square. Understood? Hence, x will become equal to C1 constant e to the power t minus e to the power 2t. So in place of C1, I am writing this. It means it will become e minus e square. So this is the value of x now. Okay. Now what they have asked? They have asked at t equal to 2, x is what? So this is my question. So put it here. X will become at t equal to 2 means e to the power 2 minus e to the power 4 divided by e minus e square. So now you can consider is e square minus e square whole square divided by e minus e square. So you can write it a square minus b square is a minus b into a plus b, e square, sorry, a minus b, e minus e square into e plus e square divided by e minus e square. So this will be cancelled and final answer is e plus e square. So x is e plus e square. Okay, note down this. Done now.
Yes, sir.
Okay, now a different question I will give. Solve d2x by d square minus 2 dx by dt plus x is equal to 0. Okay, here boundary conditions are x0 is equal to 0, x dot 0 is equal to 1. Find xt is what? So this is the question. So I already told you because t is the time. So once it is a time derivative, so we will utilize dot for that. If it is dy by dx, so then we will utilize dash for that. So that also you have to remember. Okay. So here fd equation is d square minus 2d plus 1. Okay. And this is the fd equation. So auxiliary equation will be d square minus 2d plus 1 equal to 0. This implies 1 1 ja 1 minus d or d square minus d, or simply it is d minus 1 whole square is equal to 0. 1 second. Okay, so here d minus 1 into d minus 1 is equal to 0. It means d is equal to 1 1. Understanding this? So this is the different case because here roots are real and real and same. Roots are real and same, or you can say root is repeated. So once root is repeated, so your constant will be c1 plus c2 into x, like that. So solution is y equal to c1 plus c2 t. Sorry, in place of y we have to write x. X will be c1 into c2 t e to the power mt. Actually, in some books you will find whenever they write this auxiliary equation now, so in place of d they use m. So that's why this equation become in the form of m, and procedure we have understood in the form of m only. So that you can make a habit. So that in place of d you write m square minus 2m plus 1 equal to 0. So everything will be m. Okay, so next question onward, we will write auxiliary equation. Whenever we are writing auxiliary equation, so then we will write m. Whenever it is fd, so it is d form. Okay, so it is mx. So now writing c1 plus c2 into t into e to the power x. Okay, so answer is this. Now you have to apply the boundary condition. Note down it.
So it's is e to the power t, right?
E to the power, yes, mt. Done?
Yes, sir.
Okay. So apply boundary condition. So in the boundary condition, x0 is equal to 0 means put t equal to 0. So this implies left hand side is 0, c1 plus c2 into 0 and e to the power 0. So it means c1 is already 0. Hence x will become c2t into e to the power t. Now we have to find out c2 value. Okay, so again we have to find x dot. X dot will be c2, because it is t into t to the power t, so we have to differentiate with respect to t. So c2 t into e to the power t plus e to the power t. Now in that you put at t equal to 0, x dot 0 is 1, and that will be right hand side c2 into 0 plus e to the power 0, means it is c2. So this implies c2 is equal to 1. Okay, hence x will become t into e to the power t. So this is the final answer. And sometime he can ask you how to draw it. Okay, so how to draw it? Actually, if it is only x equal to t, suppose on this axis it is t, it is x here, it is 0, 0. So first of all, we have to check whether at t equal to 0, it is going 0. Yes. So it means it will start from here. Then if it is x equal to t, that must have gone like this because it is exponential. So in exponential, it will fast grow. Means 1 plus t square plus t cube by factorial 3 factorial 2 like this. So it will grow fast. It means it will grow like this. So this is the final curve for that. Okay, in terms of curve also they can ask. You have got this answer, but in the options, no, they are asking in terms of curve. So sometimes just one step ahead is the answer, but you don't know how to draw the curve. So then your all the labor is finished. Okay. So like this, some skill is required everywhere. Note down this.
Done, sir.
Okay. Now there may be some question on the basis of mechanical oscillator. Mechanical oscillator means they are having some oscillations also. Okay. And there is a force. So you can write the force, actual force, that can be combination of damping force and some restoring force. If they all are there, so they will also make a second order differential equation, because you know force is ma, F equal to ma, and acceleration is d2x over dt square. Okay, double differentiation of position with respect to time is known as acceleration. So mass into acceleration is the force. Now damping force. Damping force is actually, it is a drag force. And this drag force, it depends upon velocity. If velocity is more, drag force is more. If velocity is less, drag force is less. So directly with some constant, you write the velocity. Velocity is dx by dt. So suppose there is a constant b, drag constant into velocity dx by dt. But because it is a drag force, so it will always, it is dragging. So it will always working in the negative direction. So this is always negative. Now coming to restoring force. Restoring force, you have seen that whenever this is a mean position, your pendulum has gone away. So then it is trying to get back to mean position. It is going away, again it is trying to get back to mean position. So this is also, it depends upon position. How much position, if more position is more, this force will be more. So it means with some constant, it depends only on position. This damping force, it is a drag force. If suppose this body is going through some air and air is having some dragging, so that drag force will work back, and it depends upon velocity. Here it depends upon position. So that's why with some constant, velocity is multiplied. Here with some constant k, restoring constant, we are multiplying with position. But restoring force also working negative. If it is going in this side, restoring force will work negative side. So that is also negative. So if I make a equation from these force combination, so this will become m d2x or dt square plus b into dx by dt and plus kx is equal to 0. So this equation has become a second order differential equation. Okay, so it can be solved with the same method. Okay, so here in such type of equation, auxiliary equation will be, now I told you that okay, so from here what you can do, this m mass, because you have to clear this, d2x by dt square, so equation will be d2x by dt square plus b by m into dx by dt and plus k by m into x equal to 0. Now these can be given some another factors. So we can write it d2x by dt square plus b by m, suppose I am writing it gamma, into dx by dt plus k by m. I know that this is the angular frequency. Angular frequency omega by omega is under root k by m. So k by m will become omega 0 square. So I can write it omega 0 square into x equal to 0. So this is the exact form of second order differential equation for a mechanical oscillator. Okay, and for this, if you want to find out the solution, so here auxiliary equation you have to put. So auxiliary equation will be m square plus gamma into m and plus omega naught square equal to 0. So like this will be your auxiliary equation. Okay, so for that, if it is okay, then you can solve it. If it is not okay, you can use the direct Sridharacharya formula. Note down this. Done.
Yes, sir.
Okay, so how to solve such problem? Using Sridharacharya formula. So m will be minus b, b is gamma, plus minus under root b square gamma square minus 4 into a is 1, c is omega naught square, divide by twice into 1. So like this you will find it. Okay, so I can simplify it. In place of taking gamma, if you take 2 gamma, I can say just it is for to understand the things. Okay, just I am taking it because this is a constant, I can take that. So that will be 2 gamma. So it will be 2 gamma and it will be 4. So 4 will come out and 2 to 2 cancel everywhere. So it will become minus gamma plus minus under root gamma square minus omega square. So this is the root. These are 2 roots. Okay. Now there will be two cases. If gamma greater than omega naught, so then this will be a real thing. Okay. If gamma greater than omega naught, so then this will be a real thing, and we don't have any imaginary value. So these are two distinct root, real and distinct root. So for that, because gamma is more, so gamma is the constant for damping force. So it means we will get the damped solution. Now, second case can be if gamma small than omega 0, so then it will become an imaginary value. So imaginary always give you oscillations or sinusoidal. So then you will get oscillatory or sinusoidal. Sinusoidal means their sine and cos will be there. Sinusoidal solution. So sometime if you solve the problems and if you are not able to recognize whether it is a damped solution or oscillatory solution, because in option they can give that it is a oscillatory solution or damped solution, so then you will be confused. So this type of a skill you should develop. Okay, if gamma is greater than 0 and these values are real, and because gamma is the constant for damping, so damping solution will be there. If gamma is less than 0, it is a imaginary, and imaginary thing always give you sinusoidal or oscillatory solution. Okay, so note down this quickly, then we will go to some problem.
Sure. The above a m square plus go up little.
In previous page,
Yes, sir. Sir.
here b by m, I am putting 2 gamma here. What is your doubt?
So how are we getting m square?
How we are getting m square? I told you na, this is FD. Tell me, FD is what?
Oh, okay, sir. Instead of d, we put m. Okay, sir.
D square plus 2 gamma d plus omega naught square. That is my FD na. So in place of d, just place m. So it will become m square plus 2 gamma m plus omega naught square. This is just to get the roots. That's all.
Sir, here mass is also there, so I was confused.
No, no, that time is another.
Well, sir.
Okay, so next thing is the I want to tell you one more curve. Suppose in some question, okay, this is your homework. Solve d2x by dt square plus 2 dx by dt plus x is equal to 0. So this you have to solve, and boundary condition is x0 is equal to 0, x dot 0 is equal to 1. These are the boundary condition. Okay, so for that I am giving you answer. Answer will be x equal to t e to the power minus t. Okay, so sometime he can ask answer to plot it. So how to plot it? Because x equal to t will go like this, but e to the power minus t, this is exponential decay. So initially this term is dominating. Initially dominating. Okay, afterward it will dominate. After some time it will dominate. Why? Because it will get more power value, 1 by t square, 1 by t4, 1 by t cube, like this. After some time, initial value is 1 only, so that's why initially this is dominating. So initially my curve will go as per the x equal to t, and after that it will start decreasing exponentially. Okay, so then this curve will go like this. So you should get that type of a skill that we can make the combination of two graph. Note down this. So here I am denoting x, here t. One more question is there. This is also homework. Solve y double dash plus y dash plus 0.025 y is equal to 0. Here boundary conditions given are y0 is equal to 3, y dash 0 is equal to minus 3.5. Okay, here answer will be y equal to 3 minus 2x e to the power minus x by 2. So this will be the answer. Okay, so here in such type of case also they can ask you the curve. So for that curve, what you have to do, you have to find maxima and minima point. You know how to draw the curve. At x equal to 0, what is the value? That is my first thing. At x equal to 0, y is equal to what? That you have to check, and there you can note down. If x is equal to 0, so that y will be 3 here. Okay, so it means my curve will start from here. And then what it will go, because it is negative and this is also negative, so from 3 it will go down, and it is exponential decay. Initially it will go slow down, after that it will go fast down, like this it will go. Okay, now see, initially this will dominate, so then it is going down, but after reaching at some value, this is minus, from here minus term will come, so then minus term will become positive, so then it will try to go positive. So like this it will be the curve, and this minima point is at what point, that you can find out from minima maxima point, because this is the minima maxima point is this is the maximum, this is the minima point, and you can find out at what value it is minima, you can find out. So this will be x minima, this is x, this is y. Note down this. Done. Next. Next, this is the Wronskian. We have already used it. So actually this is from the matrix form, but here also it is required. And we here W is the silent. So we say it like this, Wronskian. This is we speak it. Okay, pronunciation. So how we find the Wronskian? Number one, second order homogeneous differential equation for second order homogeneous differential equation d2y over dx square plus p dy by dx plus qy is equal to 0. Okay, so actually we get two roots. So in two roots, the answer will be c1 into some form of answer, so that I can say y1, plus c2 into some form of answer, that I can say y2. Okay, if y1 y2 are the two form of answer, mean these are the main terms. Main terms will depend upon these. With constant this, what is the term? With constant this, what is the term? That will be working as main term. So I told you there that day someone was asking why we are not taking C1 and C2. No, in one scan, to find out the Wronskian, you have to find out main terms only. So the main term only play the role. Okay. Now here y1 and y2 are two solutions of differential equation. Now there is a condition that y1 and y2 can be independent to each other or they can be dependent to each other. So these are the two conditions here. So case 1, or before starting the case, I will tell you the, so Wronskian can be written as W equal to y1 y2 y1 dash y2 dash, like this. Okay, so this can be the, or you can say W equal to y1 y2 dash minus y2 y1 dash. Okay, now here the condition start. If W is non-zero, then y1 and y2 are linearly independent. This question come many times. They will give you this and they will ask you whether the solution of this equation are linearly independent or dependent. So if they are linearly independent, so then it should not be equal to 0. And if W is equal to 0, it means they have the relation in between them and they are linearly dependent. So if W equal to 0, then y1 and y2 are linearly dependent. Note down this. Okay. Number second thing. There is Abel's formula, or you can say it is second definition of Wronskian. Okay, so according to Abel's formula, the Wronskian can be find out. One formula is that you can find out from determinant of y1, y2, y1 dash, y2 dash, or directly also you can find out W will be equal to some constant e to the power minus integral p dx. In integrating factor, it was e to the power integral p dx, but here it is minus sign with that. So that you have to remember. And these are the condition from this integral p dx is as per the limit. If limit is x0 to x, so then as per limit you have to integrate it. So this is the Abel's formula. So from that also you can find out the Wronskian. And C is equal to W, and W is already function of y1 at initial point x0, y2 at initial point x0. Means here also it is not leaving the y1 and y2 completely. This C is equal to W, because at initial point, when you use the initial point, so C will become equal to W at initial point. C is a constant. That value will be W at initial points. At initial point x0. At initial point x0 in y1, but W will be the function of y1 and y2. In y1 and y2 you put x0. X0 suppose it can be 0. So in place of x you put 0. So then you will get y1 and y2, and with them there will be a value of W, and that is the constant. Okay, so boundary condition will be given to you. From that we can always find out the constant. So it is same thing. Okay, now there can be use of this Wronskian if one solution you know out of y1 or y2, one solution you know, and both are dependent to each other. So then other one you can find out by using one. Okay, so we can write here, if one independent solution is known and W is also known, W is also given, or so we can calculate other solution. Okay, so for that, suppose one independent solution means y1 is known and W is known, so we can calculate other solution y2. So formula for that will be y2 will be equal to y1 into integral W by y1 square dx. So with this formula you can find it out. Okay, so we will solve some problem on this topic. You can note down it.
Sir.
So directly I am taking one net question, 5 marks question it is. Let x1 and x2. So this thing also we have to correlate, because whatever the procedure and formula we learn in the form of y1, y2 or y and x. Okay, but in the exam question comes sometime position and time. So that will also follow the same thing. You have replaced y by x and you have replaced x by t. Okay, so in place of dash, dot will be there. So this thing you can correlate and you can solve, you can apply the same method. And symbol also they will change so that you are confused. But you correlate it wisely, then you can solve the problem. Let x1 and x2 be the two linearly independent solution of differential equation d2x by dt square plus 2 dx by dt plus ft into x is equal to 0. So this is the differential equation. If now see how they are giving the symbol, and they are simple thing only. Xi t is equal to x1 x2 dot plus x1 dot x2 comma xi0 is equal to 1 and then find xi1 is equal to what? So this is the question. Tell me what you understand from here. What is this xi t given here? Can anybody tell? Okay. Huh? Now, what?
Is it Wronskian function?
Yes. It is Wronskian. See here. I told you the definition of Wronskian is y1 y2 dash minus y2 y1 dash. But because my y has been changed to x and x has been changed to time, so in place of dash it will become dot. It means here some xi is given and xi is having x1 x2 dot minus x2 x1 dot. So this is the Wronskian only. So like this, if you have practiced, then only you can understand what is he is giving. So it is very simple question, but you will be confused by seeing this term. So it is my Wronskian only. Okay?
Sir, the sign is plus here.
Huh?
Sign is plus. Wronskian is
Sorry. No, it is minus. It is my mistake. It is minus only. Okay. So you can say here, and I told you one formula. You can find out directly the Wronskian value, because ultimately what he is asking in the question, rho, xi1 he is asking, means value of Wronskian at 0.1 he is asking. So how I can get this? If I know the value of Wronskian. And how to find out the Wronskian directly? How to find out the Wronskian?
Abel's formula.
Second, Abel's formula. So this you can use. And here C is at initial value. This is at initial point now. At initial point value of C they have given value of omega. This is the value. So this will work as C. So everything is given. So just you have to understand the things. Okay. So you can say by, or first you declare it here. xi t is equal to x1 x2 dot. So this formula is given, we will not use it. So just it is to recognize that this is the Wronskian. Is Wronskian. So this is Wronskian. So by Abel's formula, xi t will be equal to c e to the power minus integral p dx, and value is x0 to x. Okay, now these are the limits. So now actually in terms of t I am calling here. So here my they have given initial value is 0, final value is 1. So from here I can take these limits. So initial value is 0, final value is 1, and in place of x I have to use t. So it is 0 to t p dt. Simple. So now it will be c into e to the power minus integral 0 to t p. What is the value of p from here? 2. Understood? So that will be c into e to the power, it will become 2t. Simple. Okay, now find the value of c at t equal to 0, xi 0 is equal to 1, and that is the value of c, because c is the value of Wronskian at initial point. I told you in the definition. C is the value of Wronskian at initial point. So that is the same thing. Okay. Hence, Wronskian will be xi t will be 1 into e to the power minus 2t. Finish? Now. So they are asking what is the value of Wronskian at t equal to 1. So just put t equal to 1, it is e to the power minus 2. And there were four options: e to the power 2, e to the power minus 2, e to the power 1, e to the power minus 1, like this. So this is the answer. So this was the 5 marks question in the NET exam. Okay. So note down this.
Good, sir.
Okay. One more question I am taking. For d2x by dt square plus omega square equal to 0, find Wronskian. Okay. Now, okay. So how you will do it? Again, here auxiliary equation is m square plus omega square equal to 0. So m will be plus minus I omega. So solution will be x will be, because e to the power 0, this alpha value is 0 and beta value is omega. So e to the power 0 into t, or I will write it full. So x will be e to the power 0 into t a cos beta t. Beta is omega plus b sine omega t. So this is the answer. Now I told you what are the main terms here. A cos omega t plus b sine omega t. So these are the main term. It will work as y1, it will work as y2. So in place of y1, y2, they will be x1 and x2 here. It will work as x1, it will work as x2. In green function also I have used the same thing. Okay, so these will work as x1 and x2. So x1 and x2 are two functions. Two functions for solution. So Wronskian will be simply x1, x2, x1 dash, sorry, dot here it will be dot, x2 dot. So it will become x1 is cos omega t, x2 is sin omega t. So dot of that minus of omega sin omega t, dot of this omega cos omega t. So that will become equal to cos omega t into this omega into cos square omega t plus omega into sin square omega t. So answer is omega. Like this you can find out the Wronskian. Okay, suppose I can make here one more question. Next question is, because all the three concept of this theory will be covered here. If a second order differential equation has because here Wronskian is not equal to 0, so they are independent only. If second order differential equation has one independent solution, cos omega t, and its Wronskian is omega, then find second independent solution. Okay, that is the question. So you can use this third formula here. This one. This is the same thing. One independent solution is given and Wronskian is given. So then this you can use. So it will become x2 equal to x1 integral w divided by t x1 square dt. So x2 will be x1 integral w divided by x1 square dt. So now put it, x1 is cos omega t integral w is omega only divided by cos square omega t dt. So this cos square omega t is sec square t. So it will become cos omega t integral, omega is constant, it can come out. So only t is the variable. So it will become sec square omega t dt. Sec square omega t is tan omega t. So it will be cos omega t into omega into tan omega t by omega. Omega to omega cancel. So cos omega t into tan omega t. Tan omega t is sin omega t by cos omega t. Cos omega t to cos omega t cancel. So answer will be x2 equal to Sine omega t. And this is we have seen here. Okay. So all the concept have been cleared now. So you can note down now. Note down it.
Sir, will Wronskian be constant always?
Huh?
Will Wronskian be constant?
Yes, this is the determinant value, no? Actually, it will depend. The Wronskian also will depend upon t, because because it is a function of t or x. So then it will depend. Then it will depend upon condition. So when you apply the boundary condition, so then you will get the constant value. Okay, so it also depend. Sometime it is constant, sometime it depend upon the variable, your independent variable. It will depend on independent variable.
Then, sir.
This page also done now.
Yes, sir.
Okay, so we will stop here. So then tomorrow we will see the non-homogeneous second order differential equation.